Welcome, Mindsetters, to another exciting lesson here at Learn Extra. Guys, today we're doing grade 12, Maths Lit, and I'm here with the awesome Peter. I'm his wingman today, you know. This is how we roll. We roll gangster like that. Yo, yo, yo.
Okay.
No. Peter, why do you always have to leave me hanging? But anyway, Peter, tell us what's happening today.
All right. Well, first of all, hi there. Great to be back. Apparently, last week you were all stalking me and trying to find out exactly where I was, okay? And there was a bit of a challenge question. So I'm going to walk across there and actually show you where I was. And you can tell the people about where the website is and all that stuff while I take my walk.
You do that.
Yeah.
Well, he takes his very long, short walk to freedom, which is the board. Yeah, I was still working on that joke. Didn't come out quite a
No, it didn't.
But anyway, guys, you know the drill. Make sure you get to Facebook page, www.facebook.com/learnextra. And if Twitter's your thing, tweet me at learnextra. And guys, I'm going to hand you over to Peter, who's going to take over the show.
Right, so last week you started looking at different scales and things and maps, and you were looking at map work. Well, apparently you were, and you should have as well. But one of the challenging questions, or the challenging question, was basically, where was I this time last week? And the truth was, I was in a town called Zeist, okay? And Zeist is in the Netherlands, right? So if you look at that, from where the studios were or are, we were at a bearing of 26 degrees south and 28 degrees east. I was 52 degrees north. So I was on the other side of the equator, right? And 5 degrees east. So just a little bit to your left. Okay. And I want to tell you this, hey? Netherlands is the most amazing country. It really is. The fact that half of the country is below sea level. And in order to keep it dry, they got to pump water from the land, okay, and they somehow all the water is channeled in canals, and they pump water from those canals on a continuous basis back into the sea to make sure that the water in the canals doesn't start rising to the same level as the sea. Otherwise, you're going to have a lot of wet people. Right, so that's where I was, and to give you a greater idea, some people were saying that I was in Utrecht. But if you look at it very carefully, you can see where Amsterdam is, right over here. Let me get a green pen here. Amsterdam over there, and I was over here in Zeist. Some people said I was in Utrecht. Well, I was pretty close, eh? In fact, we actually traveled to Utrecht on 2 occasions to play different hockey matches. So that's the answer to the challenge question. In fact, in the studio today, I brought a few things that I got from Holland. And one of the things are these actual clogs that are made out of wood. Now, obviously, this is a very small one. In fact, they made this into a money box, so I bought it for my son. Hopefully, he's going to save. Should have bought one for my wife as well, and we could have had more money. But nevertheless, here it is, a wonderful little clog. You can see how wonderfully they make them and everything. And if you make it by hand, it takes between 3 and 4 hours to make one of them. However, with modern machinery, they can make it in less than 5 minutes, which is absolutely incredible.
It's pretty handy.
And they make over 2 million pairs of clogs a year. 1 million for their use, and 1 million for people like me who go there and say, oh, I've got to buy a set of clogs. I still don't know how you walk in them. But it's incredible that people still use them today. And we also had the wonderful opportunity of going off and seeing, what are these flowers? Tulips.
Tulips,
okay.
yes.
And I couldn't bring a tulip into the country because we're not really allowed to. So I just bought a wooden one on a magnet. But the most important thing is this, chocolate. Oh my Gideon. The chocolate made in Belgium and the chocolate made in Holland is absolutely brilliant. In fact, I brought in a whole slab all the way from the Netherlands for the folk in the studio. So on the next ad break, our producer's going to send someone running in here to grab this, and I'm sure they're going to eat it all before the following ad break.
That's if I don't get to it first.
That's if you don't get to it first. Okay. So producer, this one's for you guys. Okay. So why am I all telling you that? Well, I'm telling you that for the following reason. I have no idea. But while I was on the plane as well, I managed to pick up one of the airline's books. And in the book, they had wonderful pictures of the aeroplanes. And can I come closer? Here we go. Can you see those? All right, I'm out of the light. There we go. Okay, so you can see these aeroplanes that this particular airline has. But the thing I found interesting was at the bottom, and you won't be able to see it, but at the bottom over here, there's an actual thing called a scale. And so if I took a ruler and I measured the length of that aircraft, used the scale, I could actually work out the real length of that aircraft. And so when I was looking through this magazine, I thought, here's some exam questions that I have found. And they're wonderful questions. So if any of my students are watching, I try and get a copy of this magazine, but I'm not going to show you which one it is. Okay, and that brings us to what we're discussing today. My giddy aunt. So this was a long introduction, hey? But our topic today then is all about scales. Let's go. Here we go. Scales and models. All right? Let's get started straight away. So, using a scale. A scale can be drawn in two different ways. A line or linear scale and a representative fraction or a number scale is what I prefer to call it. So a line or a number scale is when you look at the bottom of a map and you actually see the scale drawn as a line. And we're going to look at an example of that later on. Whereas a number scale, it tells you one represents another number. Like one represents 250,000, or one represents 500,000, or one represents 2 million. Okay? And so both of those scales can be used in different contexts. All right. And we're going to talk just now about one represents 1 watt. Okay. What is 1? 1 centimeter, 1 meter? We'll talk about that later. Okay. Let's go straight on. So here we go. Complete the table if the scale is now 1 is to 1,155,000. Okay. Now, let's have a look at the scale and just analyze that for a minute. 1 represents 1,150,000. 1 watt, okay? 1 watt represents 1,150,000 watt. And my students always ask me that. They always say, sir, 1 watt. Is it in millimeters? Is it in centimeters? Is it in meters? You've got to tell us. No, I don't. I don't have to tell you that at all. Because it could be one of any unit. 1 millimeter represents 1,150,000 millimeters. 1 centimeter represents 1,150,000 centimeters. 1 meter, okay? In fact, you could even say, you know what? 1 length from my elbow to my wrist represents 1,150,000,000 of the same lengths in real life. So 1 little unit on the graph, and that unit can be any unit, millimeters, centimeters, meters, kilometers, represents 1,150,000 of the same units in real life. Got it? Okay? So I don't want you asking your teacher 1 watt. Is it millimeters or centimeters? Doesn't matter. As long as the units are the same on both ends. Okay, so you can decide what that's going to be, whether you're going to work in millimeters or whether you're going to work in centimeters. So, on the map, we take a map and we measure 35 centimeters. Now, that distance on the map of 35 centimeters represents how many kilometers in real life? How are we going to work that out? Well, let's have a look at it. Okay, so the first thing we're going to say is this. Let's get some more space. I've got 35 centimeters, okay, and it represents a certain distance in kilometers. Now, what does 1 centimeter represent? Well, 1 centimeter represents, we're told, 1,150,000. 1,150,000, oops, let's write that properly, 1,150,000 centimeters in real life. Okay. Right. So what does 35 centimeters represent? Well, how did we get the 1 to become 35? We took the 1 and we multiplied it by 35 to get 35. So I started with 1 and I multiplied by 35 to get 35. So what I do to this side, I've got to do to this side. Okay? Because what's good for the goose is good for the gander. In other words, what you're doing to one side, you've got to do to the other side. What you do with one ratio, you've got to do to the other ratio. And I love using this example, where I always say the following. I say, let's pretend you go home and your mother and father call you in and say, we'd like you to know that we've given your sister an extra 1,000 rand a month pocket money. And you get all excited now, hey? Why are you getting excited? Because you know if your sister got an extra 1,000 rand, you too are going to get an extra 1,000 rand. But then your parents say, no, we just wanted you to know that you're not getting anything, but we thought we'd just tell you about your sister, okay? You'd be absolutely shattered. How can that be? That's not fair. Because if you increase my sister's pocket money, well, man, you've got to increase mine as well, okay? Imagine if they called you in and said, look, we want you to know that we're going through a bit of financial difficulties, and so this month we've decided to take 200 rand off your pocket money. However, we love your sister a whole lot more and we're keeping her pocket money the same. You'd be absolutely shattered, okay? You'd be devastated. In fact, sure, I'm having a bit of deja vu here, okay? Going back to my childhood. But let's pretend your parent loves you both the same. Okay? So your sister's money, or your money's going down, you expect your sister Issa to have a drop in salary. If her pocket money goes up, you expect your pocket money to go up as well. So I'm taking this side, I'm multiplying it by 35, I'm going to do the same to this side of the ratio. So 1 becomes 35. So what does 1,150,000 become? Well, let's have a look at that. So I'm going to take out my calculator and say, right, I've got 1,150,000, 1, 2, 3. I'm going to multiply it by 35, and I'm going to land up with an answer here of 40,250,000. Okay, so I've now got 40,250,000. 40,250,000 what? Well, this side's in centimeters, so this side has also got to be in centimeters. But my question didn't ask me how many centimeters is it in real life. The question was, how many kilometers is it in real life? So in other words, I've got my answer, but it's in centimeters. We've got to change it now to kilometers. So what have we got to do? We've got to change the centimeters to meters, and then from meters into kilometers. Okay, so let's do that. We take out our calculator, and we're going to say, right, I've got centimeters. I'm going to divide it by 100 to get it into meters, and then I'm going to divide it by 1,000 to get it into kilometers. Okay, equals, and voila, there's your answer. It is 402,5 kilometers. So we got 402,5 kilometers. So using that scale, if I measured a distance of 35 centimeters, and that would actually represent in real life 402,5 kilometers. Let's have a look at another example quickly. And I'm not going to do many of these. I'm just going to do another one. Let's look at this one. I now tell you I've got a distance in real life of 345 kilometers. How many centimeters is it going to be? Right, so 345 kilometers. So we've got 345 kilometers in real life. I want to know how many is that going to represent on the graph. Okay? How long is the distance on the actual graph? So let's make it 1 kilometer. Let's say, well, how many centimeters on the map or kilometers on the map would be represented by 1 kilometer in real life? Always try and get it to 1. So I'm going to say, right. First of all, what's our scale? Our scale says this. It says we've got a scale of 1 is to 1,155,000. So I've got a scale of 1 is to 1,150,000. Let's take this, okay? We're going to pretend it's 1 what? Let's pretend it's 1 kilometer, okay? Represents 1,150,000 kilometers in real life. But we don't want to know 1 million kilometers, okay? We want to know 345 kilometers. Okay, how do we get it to 345? Before we make 345, let's find 1. And 1 is a wonderful number, guys. Whenever I work with ratios, I always say to my guys in my class, you know what, guys? Before you try and find 345 or 10,000 or 5 or 6, try and find 1 first. So that's what we're going to do. So before we get to 345, let's get to 1. So I'm going to say, right, 1 kilometer is what? Well, how did I get that to become 1? I divided by 1,150,000. So we're going to do the same here. We've got 1 kilometer. I'm dividing it by 1,150,000. Can you see that? Okay. Now, I'm now changing it to 345. How did I get this to 345? Multiplied it by 345. What am I going to do this side? I'm going to multiply by 345. So let's do that on our calculator straight away. I'm going to say, okay, so let's just clear that. I've got a fraction of 1 over 1,150,000. Okay. I'm going to multiply that by what? By 345. And I'm going to land up now with an answer of 3 times 10 to the minus 4. Or I had 3 over 10,000. Let's leave it as 3 over 10,000. I know that's not the ideal answer, but we haven't got to our final answer. So I'm going to leave it as this, 3 over 10,000. Let's do that. So that is equal to 3 over 10,000. 3 over 10,000 what? 3 over 10,000 kilometers. All right. So we know in real life, I get in my car, put it in first gear, then to second, then to third, then to fourth, then to fifth, and that's the order we do it. If my mother-in-law is watching, please take note of that. Okay? And eventually we're traveling at a wonderful speed. I travel 345 kilometers. If I were to measure that distance on the map, the distance would be 3 over 10,000 kilometers. But guys, that's impractical. Okay, to say I'm going to measure a distance on a map in kilometers. We've got to change it to centimeters. Now, how do I get that into centimeters? Well, I've got an answer in kilometers. To change an answer from kilometers to meters, we multiply by 1,000. Now we've got an answer in meters. To change it from meters into centimeters, we multiply by 100. So we're going to say times 100. And my answer is 30 centimeters. Excellent. So let's just do that quickly. 30 centimeters. So I know a distance of 345 kilometers in real life is actually only 30 centimeters on the map. Okay. Is that good?
Makes sense to me.
Okay. Now, I'm going to want to do this again because what we're now going to do is, I think I'm going to do it. Am I going to do it? No, I'm not going to do it. What I'm going to do is we've got another question here. I know we've got 2 minutes and 8 seconds before our next ad break, but I know our producer has seen the chocolate. The woman is drooling at the mouth, demands that we take a break almost instantly so she can send someone into the studio, grab the chocolate out my hand, and go bolting out. So I think we're going to take a break. I don't know if she's aware of that.
Yeah,
yes, it is.
I think
it's
so.
an ad break.
Yeah.
And she wants the chocolate.
All I can say to my producer is, good luck getting here before I do. Anyway, guys, we'll see you soon after this break. Yep. Welcome back, Mindsetters. I've just finished my chocolate, so I don't know. Like, it's wow. I'm taking the moment just because it was. Whew, that's some good chocolate. Thank you, Peter. That was some. Whew, that hit the spot. But anyway, guys, keep chatting to me on the Facebook page. Damn, that was some good chocolate. Whew. Guys, keep chatting to me on that page. And guys, keep sending in those questions. If you don't send in questions, I can't help you. I know you're having fun, but guys, we're also trying to help you out here. Peter, take it away.
All right, so we're talking about scales and things like that. Now what we're going to do is, instead of looking at a map, we're going to look at a scale drawing. Okay, so one day when you're a lot older, you might decide, you know what, I want to build a house. And in our country, before you build a house, you've got to have a plan of the house. And once you've got the plan's got to be drawn to scale. In other words, you can't just draw a rough little sketch, say that's what my house is going to look like. It's got to be perfectly drawn. Okay, so that the builder can look at it and say, all right, from this diagram, I can see you want a house so long, I can see you want it so wide, you want the bedroom so big, you want the bathroom so small, whatever the case may be. And this next question, we look at something very similar along those lines. So let's have a look at it. Sandy intends to build a house. He has drawn a sketch to help him decide the layout of his house. The sketch uses the scale 1 is to 100,000. Help him use his sketch and his scale to calculate what? Well, before we even look at the question, let's just have a look at that scale diagram. Now, having a look at it, you can see that we've actually got a 2-bedroom home here. It has a bathroom, a kitchen, a living room, and it looks like what could be a little passageway. Okay, and the passageway, obviously from the passageway there'd be a door into the bedroom and the bathroom and the other bedroom and the living room and the kitchen. All right, so maybe that's a bit of wasted space, but nevertheless that's what Sandy wants. You can notice as well that from the question we have a scale, and the scale is 1 is to 100,000. Now 1 watt is to 100 watt. Okay, well 1 millimeter could represent 100 millimeters. Or 1 centimeter could represent 100 centimeters. In this case, though, we know we're going to deal in centimeters. Why? Let's have a look. On our scale diagram, you can see his house is 16 centimeters wide. It's 20 centimeters long. Okay? His 1 bedroom number 2 is 6 centimeters long, 6 centimeters wide. Wait, that doesn't look like it, hey? I must just interrupt myself. I've got to do it before my wife does. When you look at scale diagrams, okay, or look at diagrams in an exam, rather, the diagrams in an exam are not always drawn to scale. So if we were to look at this diagram, and I don't know how it looks out on your TV screen, okay, but you can see more or less the length is not quite the same as the width. But according to Sandy, it is. He's making the length 6 and the width 6. So that should be a square bedroom. Okay, so don't be fooled by that diagram. Just look at the measurements. That's the important thing here. All right, so there we have our diagram. We've had a look at it. We've got a feel for it. Let's look. What's the first question? The first question is, calculate the real length of his house in meters. Okay, so how long is his house? His house is 20 centimeters. We are dealing with the scale of 1 represents 100. In other words, 1 unit on the diagram represents 100 units in real life. Or 1 centimeter represents 100 centimeters in real life. Why have I changed it to centimeters? Because the diagram was using centimeters. Got that? Okay, let's have a look at the diagram. Can you see here? Lindy's written 16 centimeters, 20 centimeters. Now we want to know the length of the house. The length of the house we know is 20 centimeters. So let's write that. We know we got 20 centimeters on our scale drawing. How did we make that 1 become a 20? We multiplied by 20. So what do we do on this side? We multiply by 20. Okay, so I've got 100. Let's get our calculator. I've got 100, and I'm multiplying it by 20. And we know what our answer is going to be. It's going to be 2,000. So I've got now 2,000 centimeters. Okay, so 20 centimeters represents 2,000 centimeters. But that's not the final answer. If I gave that answer in a test or an exam, I'm going to lose a mark. Why? Because the question said, how long is his house? But in meters. So that's what we're going to do. I've got to change the centimeters to meters. So let me get rid of this line here, because that's not my final answer. My final answer is centimeters to meters. Up comes my calculator. How many centimeters in a meter? There are 100. So we're going to divide now by 100, and my answer is 20. So I've got 20, oops, let's find a pen again. I've got 20 meters long. That's a long house, eh?
It's a very long house.
Yes, it's a long house. I mean, that is like...
Yeah, probably
Sure.
a couple of long passages as well.
I think so. Right. Got the idea? So all we did was we used scale to take our diagram. We used the scale to work out what it's really going to be in long life, in real life. So my builder looks at the diagram, says, on the map it says 20 centimeters. It doesn't mean my house is going to be 20 centimeters long. Not at all. It means it's going to be 2,000 centimeters long, which is 20 meters long. That's still a very long house. Now, what's my next question? My next question says this. Sandy intends to build a house, right? Okay, sorry, that was just the introduction. Here's the question here. What is the real area of the living room in meters squared? Okay, that's a lovely question. Let's go for it. Now, we know that area is equal to length times breadth. We've worked out already that the length of the house is 20 meters times. Now we've got to work out the breadth. The breadth of the house, if you remember correctly, is 16 centimeters. You can see it over here. So 16 centimeters is the breadth. We're working with the scale of 1 is to 100. So 16 centimeters, we're going to multiply the 1 by 16. So we're going to multiply the 100 by 16, and we're going to land up with 1,600 centimeters. We then got to change the centimeters to meters. We divide by 100 because there are 100 centimeters in a meter. So we're dividing that by 100, and we're going to land up then with 16 meters. So my breadth is 16 meters. Now all I've got to do is I've got to say, well, what is 20 times 16? Let's do that. So we're going to say, right, with my calculator, 20 multiplied by 16, and we get 320. So I've got 320 meters squared. That's the area of my house. Okay? Nice? And that's a nice question. A nice paper 2 question, because what we're doing is we're taking scale, and we're also taking a bit of your learning outcome number 3, where you're dealing with area. So we're taking scale, we're taking area, and we're putting the 2 together and saying, right, now let's look at scale, let's look at area, and mingle it up and come up with a lovely question. And that is indeed a lovely question. Right, next one. Calculate, all right, a foundation slab is to be laid below the house. If the slab is 35 centimeters deep, determine the volume of cement that will be needed to make the slab in meters cubed. All right, volume question, but again, we still working with this whole scale thing. Now, I know that volume is equal to length times breadth times height. Okay? But the length times the breadth is also known as area. So I could say my volume is area times my height. And I know what my area is. I just calculated in the previous question. Let's go back and find it. Oops, something's gone wrong. Okay.
Just hit done.
Done. Done. Okay, go. Done. There we are. Right, here we go. So my area in the previous question was 320 meters squared. So we know the area is 320 meters squared. And we are now going to multiply it by the depth of that concrete. Because you know underneath every house there's a good foundation. Or so there should be. Okay? So we've got our area, and now under that whole area we put in concrete or cement. And it's got to be 35 centimeters deep. But guys, here's the trick. We can't use centimeters. Why not? Because the area is in meters. So we've got to change the depth from centimeters to meters as well. And that's straightforward. 35 centimeters, we divide it by 100 to get it into meters. So times 0.35 meters. So what volume of cement are we going to actually use? So let's bring up our calculator. 320 multiplied by 0.35 equals 112. So we've got 112 what? Meters cubed. Remember, volume always meters cubed, area always in meters squared, or centimeters squared, or millimeters squared. Are we happy? Let's move on. Now, here's another question. And I love this question. Absolutely love it. All right. Because I just love it. Okay. So here we go. 50 years ago, planes used to fly from Durban to East London to Port Elizabeth and then on to Cape Town, instead of flying directly from Durban to Cape Town. Okay. I have a wonderful map of part of South Africa. Okay. We've got Port Shepstone, Port St. John's, East London, Port Alfred, Port Elizabeth, Knysna, Jeffreys Bay. Wonderful bit of a map here. Okay. Now the question is here, how far would the plane fly between East London and Port Elizabeth? Right? Well, we know that this is the route between East London and Port Elizabeth. That's how far we're actually going to fly. But we don't want to know in centimeters. We want to know actually in real life. How many kilometers is this plane going? Now, before we can take information or find information like that from a map, we've got to know the scale. So let's calculate, or let's look at the scale. I have a picture scale here, and it tells me that the length of this white line represents 100 kilometers. Now, how long is this white line? Well, I have a ruler. And with this ruler, I'm going to measure the length of that line. Okay? So if you had to look at me doing this, you would actually see that it actually measures round about 11.5 centimeters. Okay? So I'm going to tell you this. I'm going to say, do you know what? 11.5 centimeters represents 100 kilometers. Okay? So what does 1 centimeter represent? Well, how did I get this 11.5 to 1? I divided it by 11,5. So what am I going to do this side? I'm going to say I've got 100 and I'm going to divide it by 11,5. Now guys, you can work that answer out, but I think you're going to get a strange answer. Let's have a look at it. My calculator comes up and I say, right, I've got 100. I'm going to divide it by 11.5, and my answer comes up to 8,695652174. Yes, like, that's a horrible number. Okay? And I'm not even going to attempt to write it down. All I'm going to do is I'm going to leave it as 100 over 11,5. Now, what I need to do is I need to actually measure the distance between East London and Port Elizabeth. So let's do this. With my ruler now, I'm putting it on the screen, okay, and I'm going to try and be as accurate as possible. And by the way, where do I measure from? I look at the center of the dots. Okay, so if the dot is pretty big on your map, go to the center of that dot. All right. Are there any questions at this stage while I stick my earpiece back in my ear?
No, not yet.
Okay.
People are just saying that they're enjoying the show.
Great, back to me. The earpiece is back in my ear. Okay, now let's measure that distance from Port Elizabeth, centre of the dot, to East London centre, I'm making around about 27 centimetres. Okay? So, 27 centimetres is the distance on the map. So, we got 27 centimetres. So, what does that represent in real life? Well, I'm going to multiply that by 27. Why? Because to get it to 27, I multiply it by 27. To get that to 27, I'm going to multiply it by 27. So we're going to take what's on our calculator, 11 over, there it is. Oh my goodness, now I've really gone weird. Let's try that again, hey? It was 100 over 11,5. 100 divided by 11.5 equals, and I get 200 over 23, all right? Or I could have left it as 100 over 11.5. Let's rather do that so I don't confuse you. We are going to say I've got 100, and I'm putting it over 11.5, and now I'm going to multiply it by 27 times 27 equals, and I now get an answer. I'm going to round it to the nearest kilometer, 235 kilometers. So I've got an answer of 235 kilometers. Okay, so 27 centimeters represents 235 kilometers. Now, there's one thing about this question that's totally different to all the other questions we've done. We started off by measuring the length of that white line. Do you remember that? And we said the length of that white line was 11,5 centimeters, round about that long. All right, from this point, end of the ruler, to where my finger is. So what I did was I said, you know what? 11,5 centimeters represents 100 kilometers. Because I was told that that distance represented 100 kilometers. I was given a picture scale. I wasn't given a number scale where it said 1 is to 100. If it said 1 is to 100, it would mean that 1 centimeter represented 100 centimeters. But that's not the case. It said 1 represents, or that distance represents 100 kilometers. And that distance was 11,5 centimeters. So here's a case now where we're not saying so many centimeters represent so many centimeters, or so many millimeters represent so many millimeters, but we're actually saying that distance represented so many kilometers. And that's how then we were able to work out that 27 centimeters represented 235 kilometers. Okay? Right. My next part of the question says this. 50 years ago, determine the distance a Boeing 737 would fly if it took off from Port Elizabeth and landed in Bloemfontein. Now, guys, it's the same kind of question. Okay, we're taking off from Port Elizabeth and we're flying all the way through to Bloemfontein. So we've now got to take that measurement and do it. And I wasn't going to do it, but I will do it because we need to know that, because I know what the next question is. But I'm not allowed to do that now because my producer's telling me it's time for another ad break. And I don't know why, because I got no more chocolate.
Yeah, I think you know what, let's just say she just wants to say thank you.
I think that's it. And
person.
while she says thank you, we're going to have to take a 20-minute break because that thank you's got to be a very big one.
Yes, considering when you just told me the exchange rate, I was like, it was good chocolate. It was worth it, though. It was worth
Absolutely. Okay.
But guys...
But I think we're only taking a 1-minute break or something.
Yeah. So guys, you know the drill. It's only a minute. Make sure you come back. We'll see you after this break. Welcome back.
Sorry.
Are you really trying to take my job?
No. It's your turn.
Guys, what I was trying to say, you know, sometimes it's that sugar rush from the chocolate. Anyway, guys, I hope you had a nice little break. I hope you got your pens and your pads out and you're about to now you're ready to make notes. Now I'm on a sugar rush. You guys are ready to make notes? Guys, again, keep chatting to me on the Facebook page. Talk to me. If you're lost in here, if you need help, make sure you chat to us so we can get those questions to Peter so he can help you. But for now, I'm going to hand it over to Peter to continue.
Right, we were busy with the question where we showed you a map of South Africa, okay? And looking at that map, we then had to calculate how far it was between Port Elizabeth and East London. The next question said, calculate how far it is between Port Elizabeth and Bloemfontein. And guys, because we're under pressure with time, I'm not going to do that because we'd follow the same principle as we did. So finding the distance between Port Elizabeth and East London, we use the same principles to find the distance between Port Elizabeth and, let's say, Bloemfontein. Okay, let's look at this next question because this is a fun one. So a light little Cessna plane, and a light little Cessna plane is a tiny little thing. Hey? It's a small, squashed up plane, very tiny, mainly for two people. It's the kind of thing where you sneeze, the plane goes backwards. All right, so a light little Cessna plane carrying two businessmen takes off at Knysna and heads to Bloemfontein, where they'll have a meeting. After flying 320 kilometers, the plane loses stability, and the pilot needs to make an emergency landing. Presuming each town has a little airport, determine which town the pilot needs to request landing rights from. Show your working. Now this is a good one. Okay. I don't know if you know this time, but my wife and I were actually in a plane, not quite a crash. We were in an emergency landing. We went off on honeymoon. I kid you not. And on the way back from honeymoon, we were in a little aircraft. It was about an 18-seater, somewhere around there. And our plane hit a thunderstorm. And it really was horrific. The plane was thrown around like you cannot believe. And eventually it tipped upside down. And it was the most horrific experience. And I was actually thinking, this is great. It's taken me so many years to find the woman I love, and now we're going to die. Okay, but I was sitting next to her, and she was by the window looking at me, and I was looking at her, and I was saying, "It's okay, my dear, we'll be absolutely fine, don't worry." And while I'm talking to her, my eye looks out the window, and I see the propeller on fire. Okay, and I then realized we could be in a bit of trouble. And she must have seen the expression on my face and thought, "What's going on?" And so she, of course, from looking at me, turned and saw this, and we both realized this could be the end. At least we'd found true love before our
That's the
last
great part.
day. And the pilot then said, "Folk, we're going to have to land." Okay, and the storm had taken us right past Durban Airport, so we'd gone past that. And he said, "We're going to have to land, and we can't go back to Durban because the storm is so strong, this little plane can't get through it." And so I thought this guy's going to go on to Pietermaritzburg or Empangeni or Richards Bay. And then I looked at the pilot, because you could see him, because it's such a small plane, they can't even close off the pilots. And I looked at him, and he was doing one of these things. And I'm like, what's he doing? And true as I stand here, we landed in a sugarcane field. I kid you not. And that was one of my experiences of flying. So these businessmen are going through the same thing. But they've got a nice pilot. He's not going to land in a sugarcane field. He wants to land on a landing strip, somewhere close to somewhere close to a town. So we're going to presume for this question that every town has a little airport. Okay? Where is he going to land? Well, the first thing, folk, we're going to have to do is during the break, plotted the route. There they are. They've taken off from Knysna, and they're traveling all the way to Bloemfontein for a meeting. Okay? So somewhere along this route, something's gone wrong. And it's gone wrong at 320 kilometers from Knysna. So we need to determine where is 320 kilometers on this green line. Now we have a scale, remember? Our scale is over here in the corner. And it's saying that distance represents 100 kilometers. So let's write that down. We know that distance. What was it? It was 11,5 centimeters. Oh my giddy aunt, I've done a horrible thing here. Let's go back here. Okay, just pretend that's not there, okay? 11,5 centimeters represents 100 kilometers on real life. So 1 kilometer means it's represented by 11,5 divided by 100. Why divided by 100? Because to get that 100 to 1, we divided that by 100. So we've got to do the same this side. We've got 11,5 and we're going to divide it by 100. Okay? But we don't want to know 1 kilometer. We want to know 300 and 20 kilometers. So how far is 320 kilometers on the map? How did I make that 1 into 320? I multiplied by 320. What am I going to do with this? I'm also going to multiply by 320. So on our calculator, we've got, let's clear all that. Fraction button, where is she? There she is there. 11.5 divided by 100. Okay? And I'm now going to multiply that by 320, and we land up there with 36.8 centimeters. So I know, because remember this is in centimeters, I've got 38.6, or was it 36.8? It was 36.8. Cool. So we got 36.8 centimeters. That's where the trouble happened, folk. We're flying in our aeroplane 36.8 centimeters later on the map, which means 320 kilometers later in real life, something goes wrong. So let's draw this, or let's find this point, 36.8. So I'm going to take my ruler, and we're going to measure 36.8. Let me do it this side. I'm going to take another color. I'm going to use yellow. Okay? So from here, now my ruler is only 30 centimeters long. So I'm going to have to kind of use a ruler and a bit more. So let's go for that. So from that point, oh my goodness, I'm not allowed to do that because this line goes all funny. So let's try. 36, there we go, there's 30 and 6.8, right about over here. At that point, something goes wrong with the plane. Which airport's closer? The airport at Colesberg. Presuming, though, that every little town has an airport. And remember, we said we are going to make that presumption. So we're flying along, 320 kilometers later, we mean we're at that spot, and that's where we're going to land. I love this question because it's just so different. It's a different way of looking at at scales and using a map. And being able to put the two together and then also reason with your answer. It's a lovely question. I love giving this kind of question to my grade 11s and my grade 12 boys. Absolutely love it. If any of them are watching, I'd practice this. Okay. Yeah, you happy?
Yeah, I'm happy.
Okay. Right, let's go on. Next question. Back to our map. It now says the coastline between Knysna and Port Shepstone is stunning. Mr. JB... I don't know who JB is, but Mr. JB takes his little petrol-powered motorboat and cruises along this route. Okay? Determine the length of this coastline. So he's going to start at Knysna, and Knysna is this point over there. There's Knysna over there, and he's going all the way through to Port Shepstone. Where's Port Shepstone? Port Shepstone is this point over here. Okay? How long is that coastline? Now, guys, this is one of the questions where the geography people say, I know how to do this. Okay? What we got to do is we've got to get a piece of string and put it along the coastline so we can then measure how long that piece of string is. Because it's very difficult for us to take a ruler and say, okay, there is 4, now we got that bit, and add up all the bits. So what we do is we take a piece of string. Now, many of us, when we get in the exam, didn't know we were going to get this question. Now we need a piece of string. What are we going to do? It's simple. We take our shoe off, okay? And in our shoe, there is a shoelace. And what we're going to do is we're going to take the shoelace out of the shoe. Now, it's kind of weird when the invigilator's walking around, suddenly sees everyone do this, and the smell is not that good, so I'm going to put my shoe back on. But at least I have the shoelace. Now I have something that can make round turns and curves, and I'm able to actually kind of measure it along the coastline. Now, it's kind of hard for me to do this because I'm not working on a flat surface. I'm actually working up here, so it is a little difficult. I'm not going to be 100% accurate, but I'm going to give you an idea and teach you the concept of doing it. Okay, so what we do now is my shoelace, it starts at Knysna, up to there, goes around that corner, keeps going. At that point now, starts to go this way, there. Then it comes up a bit. We're now traveling along over there. We're now going around that corner, around this corner, and then like I said, this is very hard for me to do because I'm actually standing on a flat screen up here, and this arrow is following my shoelace everywhere along, and I have no idea why it's doing that. But that's one length, whole length. Now I'm going to do it again, and away I go, and I'm going up there around that corner, around this corner, down here, up here, and voila! My length of my coastline is one whole shoelace length plus this little bit. So what do I have to do? I have to work out how long all this is. So I'm going to go to my ruler and I'm going to say, okay, the little extra bit that I'm measuring, okay, actually works out to around about 28 centimeters. Now, please understand, I'm not accurate at the moment, and I've explained why. Because it's quite hard for me to do this. All right? You guys would be a lot more accurate. In fact, I wouldn't even encourage you to use a shoelace because it's so thick. I would take a thin piece of string into the exam were you to be given this kind of question. Okay? So we know that this little extra bit was 28 centimeters. So before I forget, I'm going to write that down here. And I'm going to say, right, I've got 28 centimeters. Plus, I had one of these whole strings. Right? So the extra bit plus this whole thing. So let's measure how long this whole thing is. Again, from there to there was 30 centimeters, and then it's going to be another 30. That makes 60, I think. And then we keep going, and we get all the way to another 13. So I've got 73, right? So we got plus 73 centimeters. So when I add that up, I'm going to actually land up with 101 centimeters. So my coastline is 101 centimeters long. Okay? But that's on the map. So what is it in real life? Well, do you remember our scale? And our scale was 11.5 centimeters represented 100 kilometers. So 1 centimeter represented 100 divided by 11.5. How did I get that? I divided this by 11.5. Okay, so I'm going to do the same here. Divide that side by 11.5. But I don't want 1 centimeter. I want to know how long is 101 centimeters. How did I get that one to be 101? I multiplied by 101. So I'm going to do the same this side. Multiply by 101. So with my calculator, we're going to say, okay, I've got 100 divide all over 11.5, and I'm going to now multiply that by 101, and I'm going to get an answer now of 800, rounded off, 878 kilometers. Okay, so 878 kilometers. That's how far it would be if this Mr. JB, was it, were to get in his boat and travel along the coastline from Knysna all the way through to Port Elizabeth. Okay. Or rather to Port Shepstone. Okay. We happy with that? Okay. Nice type of question, guys. Taking a map, bringing in a whole lot of different types of scales. I absolutely love that question. I'm aware we're short of time. Let's see what our final question was here. All right. If the motorboat uses a litre of petrol for every 4.5 kilometers traveled, determine how many litres of petrol is used. Now, how many kilometers did he go? He went, I had it on my calculator, 878. So what we're going to do is this. We are going to say, okay, so he needs to travel 878 kilometers. Okay. But for every 4.5 kilometers, he uses a litre of petrol. So we divide this by 4.5 to work out how many litres of petrol. So I'm going to say, right, I have 878. I divide it by, 4.5, and I get an answer of 195,111. I'm going to make it 195. So I need 195 litres of petrol. But every litre cost, that's all we need to know, how many litres. End of question. And I know what the next question is. It's going to be, what is the cost of the petrol?
Okay.
I'm sure it is.
I don't
It
think
is
we'll have
because it's
time.
R9.95. But I don't have time because my producer's saying I've got 17 seconds, 16
Yes.
seconds, 15 seconds.
Which-
That's me. Thanks very much.
Which means that I've got like about 5 seconds to say, guys, hope you had fun. And guys, make sure you keep checking on the page, keep talking to me. If you have any issues, make sure you use the page. It's a thing for you. And guys, we're going to say goodnight and goodbye.